So this is a typical calculus 2 improper integral, and this is the typical work that somebody might do. I want to see if you guys agree with this answer or not. Here we go. This is an improper integral because we have a vertical asymptote at -1. And to see that, if you plug in -1 into the x here and here, you get -1/0, so that's an indicator. Therefore, we will use the limit definition. We will have to avoid exactly -1. So we take the limit as some number a going to -1 from the right, and we have the integral from a to 2 and that. And the reason this is -1 plus, meaning going from -1 from the right, it's because this interval is -1 to 2. We have to go to -1 from the right. And now, to do an improper integral, you pretty much have to do two things. First is the integration. So I will tell you the result of this is ln x plus 1 plus 1/x plus 1. You don't need the absolute value because later on the input will be positive. And I do have a video going over from here to here. You guys can go ahead and check out the link in the description. And then once we have that, plugging the 2 into the x, we get this. Plugging the a into the x, we get that. That's just the integration part. Now, the second thing that we have to do when we have an improper integral is the limit. We take the limit as a going to -1 plus. So just this part, because this is just a constant. Now imagine if we put -1 plus into all the x here and here, then we get this. Now, -1 plus 1 is 0 plus, because you can think about this as -0.999. Because again, we are approaching -1 from the right. It's just like a number slightly bigger than -1. -0.999 plus 1 is 0.999 positive. That's why it's 0 plus. Similarly, this right here, we also get 0 plus. Now, ln of 0 plus, we get -infinity. 1/0 plus, we get positive infinity. -infinity plus infinity, we cancel, we get 0. So the answer is just this right here, right? ln 3 plus 1/3. What do you think? Yes, no. This is actually not correct. This right here is a very, very dangerous question because of this part right here. Yeah. Where's the mistake though? Is it because of ln of 0 plus it's not -infinity? Well, no, because if you look at ln graph, let's say if you have ln x, it does go to -infinity as x goes to 0 from the right. It goes straight down. So this right here is okay. And 1/0 plus is positive infinity. This is also okay. You can look at the graph for 1/x as well. What's not okay is this. -infinity plus infinity is not necessarily equal to 0. Well, we cannot say that. This is actually not true in here. Be really careful. This is the dangerous part right here. So how are we going to do this exactly though? The key is we have to do the limit legitimately right here. So we will have to figure out the limit as a approaching -1 plus of this function ln of a plus 1 plus 1/a plus 1. Alright, so let's go ahead and do it. So first, we are going to combine this and that, and we need a common denominator. So I will multiply the bottom and the top by a plus 1 here. So we get a plus 1 times ln of a plus 1, and then add a 1 to it here, and then over the same denominator, which is a plus 1. And now, can we just do L'Hopital's rule? In fact, no, not here. Because imagine if you plug in -1 into all the a's, here you get 0. And then if you have -1 with a plus here, you are looking at ln of 0 plus, that's what we said earlier. And this right here gives you -infinity. Okay, what's 0 times -infinity? In fact, this right here is actually an indeterminate form. So even though I add a 1 to it and all that, no, I cannot take the derivative of the top and the derivative on the bottom using L'Hopital's rule here. No. the truth is we actually have to do L'Hopital's rule right here for this part and then put the result to there. Yeah, this question is actually very tricky though, because earlier maybe you have noticed the negative infinity plus infinity. That's not necessarily equal to 0, and then you worked out this. Another trap that's happening here is people might just do L'Hopital's rule right here, right now. Don't do that. So what we have to do is, we will have to write it down right here. The limit as a approaching -1 plus of just this. And like we said earlier, we have 0 times negative infinity. It's not L'Hopital's rule ready. Let's go ahead and bring this down, because we can see that we get ln of a plus 1 over, not here, but here, 1 over a plus 1. Once we have this, we will have negative infinity over plus infinity. That's the OK form for indeterminate form for L'Hopital's. So right here, right now, we do the L'Hopital's rule, differentiate with respect to a. That's our variable. So we have the limit as a approaching -1 from the right. The top gives us 1 over a plus 1. For the bottom, write this as a plus 1 to the -1 power, bring the negative to the front. And then a plus 1, subtract 1 from the exponent, so it's -1 minus 1, which is -2. So we have a plus 1 to the -2 power, which is a plus 1 squared right here. And then right here, we can multiply the top and bottom by that. You can see this and that cancel, and then we can get rid of one of them right here. So we are just going to get the limit as a approaching -1 plus. We have a negative, and then this, a plus 1. Now imagine if you put -1 to here, -1 plus 1 is 0, and then times minus, it's still 0. So the result of this is actually equal to 0. So guess what? In fact, this whole thing is not in an indeterminate form. We cannot use L'Hopital's rule, because this whole thing is actually just equal to 0. So now I'm just going to put this right here like this. The top here is equal to 0, and then plus 1 over, and let me put the -1 plus right here. Okay, let's have a look. On the top here, well, it doesn't really matter if you are trying to figure out if this was a 0 plus or 0 minus, because when you add the 1 to it, the result is just 1. Regardless if it's plus here or minus here, the top is positive. On the bottom, this is where the little plus matters. -1 plus plus 1, we get 0 plus, because you can think about this as negative 0.999. Plus 1, we get positive 0.001, which is denoted by 0 plus like this. And this, positive 1 over positive, right? We approach infinity. So therefore, this limit here is equal to infinity. Yeah. So now let's go back to what we had earlier. So as we can see, this actually gives us positive infinity. That means negative infinity plus infinity, in this situation, we end up with positive infinity. So what we really have is this. This number, ln 3 plus 1/3, and then minus this whole thing gives us positive infinity. Now, this right here is just a constant, no matter how big this is. When you subtract infinity, the result will be negative infinity. Therefore, this improper integral here actually diverges. So this is the correct answer. We have to be really, really careful when we are doing the improper integral once we reach the limit part. If it's indeterminate form like this, make sure you do the limit carefully. And for the limit, as we saw earlier, it's also quite tricky.